Hello everyone. In this video, you will learn that derivative is obtained from the limit of a difference quotient. And also, you will learn that slope is the derivative of a function. So let's start. If we have y a function of x, then the derivative measures the average rate of change fx over an interval of x. So what does that statement mean? Let me visualize first with the graph. Here we have a graph of y as a function of fx, a visualization of our function here. So let us assume that the graph is like this. Now, let us set x null as the initial point, and the pair would be y null, where y null equals to fx null. Then, if x changes as much as delta, becoming x null plus delta x, then the y null also changes into y null plus delta x. Oh, sorry, this is delta y, y null plus delta y, which is also equal to fx null plus delta x. So you just insert this x null plus delta x into the function, and then you get y null plus delta y. Why is it y null plus delta y? Because the change of y minus y null is just delta y. From the figure here, we have that in the interval between x and x null plus delta x, fx changes, fx changes from fx null to fx null plus delta x. Now we can see that y plus delta y is just a result of fx null plus delta x. And we can rewrite delta y equals to fx null plus delta x minus fx null. I should write this as y null. Why? Because we know that y null is just equal to fx null. And if we divide both sides with delta x, we will have delta y per delta x is equal to fx null plus delta x minus fx null divided by delta x. Now we see here that this different quotient here measures the average rate of change. Because it's delta y over delta x, it measures an average rate of change of y, the rate of change of y, delta y here, over an interval of x null and x null plus delta x, as I stated in the beginning. Besides measuring the average rate of change of y, it also shows the slope of a line between the interval of the 2 points, as shown by this new red line that I just made. Now I want to show you the concept of derivative when there is an instantaneous rate of change. So what is an instantaneous rate of change? An instantaneous rate of change is a change of fx when the delta x is very small, approaching to 0. And what is the implication? So this graph here shows you, just like what we have discussed before, that the delta x is large, and this is the slope that measures between 2 points. And so what is an instantaneous rate of change? It's when delta x is approaching to 0, very small, like here. Got it? So the delta x is very small. The result, the difference quotient now uses the limit concept because the delta x is approaching to 0. And the slope now measures the slope at this particular point. So we can say that it is a tangent slope, and it's just the curve, the slope of the curve at this specific point. So based on the explanation by graph, I would like to emphasize again that the limit delta x approaching to 0, delta y per delta x is just the slope of the line tangent to a curve at a particular point. And it is also the derivative of fx with respect to x. Now you have seen how derivative is a slope of a curve. I will now show you how this difference quotient result in a derivative of an equation. So I'll use this example where y is a function of x, 3x squared minus 4. And to apply the difference equation, we need to have the fx at x null and the change after a change, fx null plus delta x. And we imply it to this difference quotient and do the operation as follow. To understand the operation in detail and slower, you can try to do it on your own by pausing the video. So the end result is 6x plus delta x plus 3 delta x. This is the derivative of this equation if the delta x is a large number. But if the change is very small, an instantaneous rate of change, then delta y over delta x is just equal to 6x null. And we know without this difference equation, we know that the derivative of this function is 6x. And this is how you get that derivative. So I have shown you how the difference quotient result the derivative of a function. Thus, the derivative of y fx can also be denoted as f prime x, y prime x, or dy over dx. This is the most general symbol for derivative. So now you have known that derivative measure a change on y as a change of x for a function of y equals to fx. And we also have shown you that derivative is also the slope of a curve of y as a function of x at a particular point x if delta x is very small, approaching to 0.